Hello, everyone, and thank you very much for attending this live session today on YouTube. And if you're watching the recording, thanks a lot for watching this video, and I hope you find it useful. My name is Ahmed Misbah, and today I'm going to be talking about Istio as an enabler for migrating monolithic applications to microservices. So, as the name of the session suggests, today we're going to be talking about a lot of things. And the agenda here shows you how the topics we are going to be talking about are going to be organized. So first I'm going to start by introducing myself, telling you a little bit about me. Then I'm going to be talking about the areas of transformation in the IT world, microservices being one of them. And then we're going to talk about migrating legacy monolithic applications to microservices. We're first going to cover some theories like what microservices are, what are their benefits, what are their pain points, what design patterns does microservice architecture offers, and what a service mesh is. Once we are done with that, we're going to talk about design. How can we design for the migration of a legacy monolithic application to microservice architecture? We're going to be talking about the approaches and the patterns we're going to be using to realize this migration. And then we're going to talk about how we're going to be migrating using Istio. And we're going to have an example that is going to be a monolithic application. And we're going to see how we are going to migrate this monolithic application into microservice architecture using Istio. And finally, we're going to be concluding the session, and I will be providing you with a couple of useful books to read in this topic. So let's start. So a little bit about me. My name is Ahmed Misbah. I'm a software architect. I am a speaker at a number of events and conferences. Some of those included the Java Developer Conference here in Cairo, the Google Developer Group, the African and Middle East Conference on Software Engineering, the DevOps Days Cairo. I've been a speaker in this event for 2 years now, and in the Orange Dev Test Days. So what are my topics of interest? Agile and lean. Obviously, DevOps. I've delivered a couple of sessions on this topic. Java. I'm a huge fan of Java. I love the language. Of course, it's not the only language which I can write, but it's basically my favorite language, and I know many people are going to be hating me for that. I love software architecture. It's my bread and butter, and it's also one of the main topics of interest. And away from the software industry, I enjoy a lot reading and watching stuff related to aviation, astronomy, and space travel. So if you're also interested in these topics, we are definitely going to become very close friends. Okay. Now let's talk about areas of transformation in the IT world. Based on my experience, I see that there are 4 areas of transformation in the IT world. These include development process, application architecture, deployment and packaging, and application infrastructure. So, in the past, the development process that was adopted by most software development teams was waterfall. And then Agile came out in the early 2000s, and teams started adopting that. And today we see teams adopting DevOps, or transforming basically from Agile software development to the DevOps way of doing things, which is an extension to the Agile mindset. Regarding application architecture, teams started with monolithic architecture, and some teams still use this architectural styles. Then when applications got bigger, teams started applying the N-tier architecture or service-oriented architecture. And then teams started to transform or move to microservice architecture, which is the trend nowadays. Everybody is excited about it, and everybody is looking forward to adopt it, whether that be in a brown project that has already started or in a green project which is about to start and really needs this kind of architectural style. In deployment and packaging, in the past we used to deploy directly to physical servers. Then virtualization came out and we started not to deal with physical servers directly. What you would do is you would spin a virtual machine on a server, and then you would deploy your application or system into that virtual machine or into a couple of virtual machines. And then containers came out, which are more lightweight and more portable and much smaller than virtual machines. And these were a game changer. They changed everything and are now considered an enabling technology for microservice architecture, or one of the enabling technologies. And last but not least, application infrastructure. In the past, each enterprise or company used to have its own servers or have its own data centers. Then they started renting hardware from other data centers, what we call hosted infrastructure. And then everything started moving to the cloud, where basically you can provision whatever you want at any time you want, and it almost seems like it's unlimited. You can do that on your own using a fancy dashboard. You don't have to submit a request to wait for some sort of VM to be provisioned for you to use. You can do all of that, and it's elastic. You can scale it up to a certain cap which the cloud provider gives you, or you can descale based on basically what you want, and you pay for what you use. So basically what companies should be targeting nowadays is to basically transform to the four areas that are within the blue box or boundary. Teams should be transforming to DevOps. Applications should be transforming or migrating to microservice architecture as long as their nature requires that. In terms of deployment and packaging, applications and teams should be packaging the applications as containers, deploying and running them as containers as well. And last but not least, teams and applications should be moving to the cloud to leverage all of the benefits that the cloud provides. And when we talk about transformation, that transformation can either be a leap. So if your application is running as a monolithic architecture and it's growing really big, its maintainability and manageability, scalability as well, are becoming a big problem. You don't have to first move to N-tier architecture or service-oriented architecture and then move to microservices. You can leap ahead or jump from monolithic architecture to microservice architecture right away. And if you have taken the incremental path, you can always move from N tier if you're already applying that to microservice architecture. So when you're thinking about transformation in one of these areas, you have these two options. You can either jump from where you are to the latest methodology or practice or architecture, or you can take it one step at a time. And perhaps this is most suitable in the development process part, but I think in other parts the leap can be applied really easily. And what I was just talking about right now, companies, teams, products, projects, migrating to these 4 areas of transformation, it doesn't stop there. So basically here, what you are transforming to or migrating to is the cloud native way of doing things. But there is actually a step further. There is another step which people are talking about and discussing right now. So even if you move to microservice architecture, and even if you adopt DevOps, even if you apply containerization and move to the cloud, it doesn't end there. There is a step ahead. Teams who are already adopting microservices nowadays are now considering moving to function as a service or serverless architectures. We are starting to adopt now the mindset of experimenting and learning rapidly, as is dictated by modern agile principles, which have been invented by Joshua Krivyaski from Industrial Logic. With COVID, people started working from home. Teams started to become more and more distributed, and not just teams, it's the individuals within the teams. So things are changing and new things are starting to come up. So while in the previous slides we were talking about teams and organizations looking forward to transforming to DevOps, microservices, containers, and cloud, this should be your goal for today. But know this, there is another step ahead. So make the move quickly, because there are still more things to come. So this covers the part of transformation in the IT world. So what we're going to be talking about today, migrating from monolithic applications to microservice architecture, this is actually an area of transformation in the IT world which you should be considering nowadays. Now, let's talk about migrating legacy monolithic applications to microservices, and let's start with theory. So first, let's talk about microservices and microservice architecture. What's microservice architecture? It's basically an architectural style that structures an application as a collection of services. These services have a number of characteristics. We can summarize those characteristics in the coming 5 points. So these services are highly maintainable and testable, because as the name suggests, it's a microservice. This suggests that it's of small size. And when we say of small size, one of the things we are talking about here is perhaps the lines of code. And of course, the less lines of code you have, the smaller the microservice is, the easier for you to maintain it and test it. Microservices are also loosely coupled, because each microservices should apply the single responsibility principle. It should do one thing and one thing only, whether that be in terms of functionality, in terms of resource, or in terms of business capability. So when you do that separation, you get a loosely coupled design and a loosely coupled architecture, which is always a sign of good design and good architecture. Microservices are independently deployable. So unlike monolithic application where you have to deploy this huge monster, once you do a very small change, and if other people do other changes in that big monster, it has to be handled using different branching mechanisms you do on the version control. You have to apply complicated configuration management in order for you to deploy perhaps a very small change in monolithic architecture. But with microservices, things are much easier than that. You can deploy each piece of business capability or each resource or each functionality independently. And so this would allow you to have continuous delivery and continuous deployment. And this would allow for value, which we have spoken about in previous sessions, to reach to the customer sooner and perhaps faster. The fourth characteristic is that these collection of services can be organized around business capability or bounded contexts. So if you're following Conway's law, where your architecture reflects the design or the structure of your organization, then most probably you will be splitting your microservices by business capabilities, and microservices can do that. They can be organized around your business capabilities, which are a mirror of your organizational structure. Basically, what teams do you have and what each component a team is developing and maintaining. Or it can be, if you're using domain-driven design, your services can be organized around subdomains or bounded contexts. This is basically where the design dictates your team structure and organizational structure. So microservices gives you this flexibility. It allows you to organize either around business capability or bounded contexts. Last but not least, the services can be characterized by that they are owned by small teams. If you're doing Agile, you know that what you're looking forward to is to have smaller teams, because these teams are easier to manage and it's easier for the team members to deal with each other when their numbers are small. It also gives you the capability to have multiple smaller teams where each one will be developing and maintaining their own services, and then they can agree on a methodology or a way that they can integrate their work with. Perhaps use the Jeff Bezos mandate for doing something like that. So these are the five characteristics of microservices, and this is what makes microservice architecture what it is. So really, the purpose of us going through these things, though you may have read about them before and they seem too theoretical, is that if you don't realize the kind of things we're talking about right now, eventually you will not be applying microservice architecture correctly. You should always keep these things in mind, because if one of them does not apply to your architecture, it's a sign that you may be doing something wrong applying this architecture. Okay, so we spoke about the characteristics of microservices. So Why move to microservices anyway? What benefits do microservices give us? First, technology heterogeneity. Since this is a loosely coupled architecture, where a small team can own a piece of business capability or basically a bounded context, each team can choose to develop that piece of functionality or business capability with whatever technology, programming language, or framework they master. So microservice architecture gives you this capability, the capability to develop your microservices using the technologies you master, because you're applying loose coupling. So it doesn't really matter. And this gives you a lot of other advantages. You will have the freedom to choose the best framework or the best programming language for perhaps the functionality you're choosing, which gives you, again, more loose coupling. The second advantage of using microservices is robustness. So what is robustness? Robustness is basically the degree to which your system can proceed as usual even after an interruption or a failure has occurred. And if you compare monolithic architecture with microservice architecture from the diagram you see in front of you on the screen, you'll see that if this whole monolith fails, the user will not be able to access any functionality, and the application will not be able to deliver value to the user, because this whole thing has failed and crashed. And even if you're using a layered design, if one of the layers fail, basically the layers on top of it will fail as well, and therefore you're going to be using a lot of the value you're delivering to the user. While in microservice architecture, this is not the case. If one microservice fails, this does not mean that the whole system will not be able to deliver value to your end user. End users will still be able to use the functionalities or the parts of the application which are still running. So basically, microservices gives you robustness in your design and in your architecture. Scalability. So in the past, when we had monolithic architecture and when you had this big application, scaling the application was always something that was expensive and at the same time took some time, because when you have a big application, obviously for this application to run, it's going to take a lot of time. While with microservices, you can easily scale only that microservice which has a lot of hits or has a lot of traffic. And you don't have to scale the other microservices which don't have similar traffic or need to be scaled. So microservice architecture gives you the capability to easily scale your functionality or parts of your application or certain components or certain services that need to be scaled independent from other services, and it gives you the capability to do so in a more cost-effective way. Ease of deployment. So if each microservice has its own CI/CD pipeline and you're using other enabling technologies such as containers and container orchestration, basically, which are really very important enabling technologies that you need to be using along with microservice architecture. Otherwise, the architecture is going to be even more inconvenient than monolithic architecture. So with all of this, you get the ease of deployment. And with ease of deployment, you get sooner deployment to the end user. Value is delivered sooner. Feedback is received sooner. And so that you would be able to compete in the market and satisfy your end users. Organizational alignment. We have spoken about this when we discussed the characteristics of microservices. So basically, you can design your microservices so that they would mirror your organizational structure. Or if you're using DDD, you can first design your microservices based on subdomains in the problem domain, and then bounded context in the solution domain. And then you can organize your teams based on your bounded contexts. Last but not least, composability. So if you're into software design and architecture, you know that composability is basically a system design principle that deals with interrelationships of components. And when you have a highly composable system, this system provides components that can be selected and assembled in various combinations to satisfy specific user requirements. And this is what microservices gives you. It gives you this high composable system where you will have different microservices providing different functionalities, and you can assemble those microservices using different patterns such as API composition or CQRS, for example, so that you would be able to specify user requirements. So you can do that when you have microservices. You can achieve this sort of high composability or this high composable system. So people say no pain, no gain. Microservices don't give you all of these benefits and advantages for free. Obviously, you will have to bear some pains. Some problems come with applying microservice architecture. And if you don't like the word problems or pains, we can say challenges. So some challenges come with applying this sort of architecture. And from the graphic on the right here, we can see that these are the number of microservices that Amazon.com and Netflix have. So you can imagine that when you have these numbers of microservices, definitely you're going to be meeting some challenges. So the first challenge is developer experience. Microservices are complex. They're not easy. They require a lot of reading, a lot of experimentation, a lot of learning, a lot of trial and error, a lot of technologies to learn. So really the experience is not that easy. And when you are, and the challenges appear from the design phase. When if you're doing DDD, you will understand that doing microservices is challenging from the first moment you decide to go for microservices. So it's challenging for developers. They have to learn a lot of stuff, obviously. So that's the first challenge. Second challenge, technology overload. Obviously, this is a distributed system. You need to have observability. You need to handle intercommunication. If you're going to use Docker, if you're going to use Kubernetes, if you're going to go to the cloud, all of these things are complex. You need to understand them, you need to learn them, and you need to maintain and manage them. So this is a technology overload which not just the development team, but all of the other teams need to bear. So technology overload is certainly a big challenge in microservice architecture. Monitoring and troubleshooting. As we've said, microservices are a kind of distributed system, and in a distributed system, when a problem occurs, the troubleshooting is very challenging, because where exactly in my distributed system did the problem occur? In which component or in which microservice did this problem occur? And obviously you have to monitor each microservice. How much resources is it using? Is it responding in time? Is it becoming slow? And you can imagine that if you have hundreds of microservices, this is going to prove quite challenging. Handling failures. Of course, distributed systems are all about handling failures. If one component fails, how are other components going to react? How can we guarantee that the system will still be able to serve the other functionalities that are not dependent on that specific component that has failed? If other components are dependent on the component that has failed, what are they going to do? So this is another challenge. Security. Obviously, this is a distributed system. Microservices are going to be located on different machines, in different availability zones. Each one will require its own handling of authentication, authorization, mutual, TLS, confidentiality, etc. So this is going to prove quite challenging. Testing is another challenging point, because for each microservice you have to have unit tests, component tests, out of process component tests, integration tests, end-to-end tests, etc., etc. And you're going to have those for each and every microservice. And things get quite challenging, because I'm going to test one microservice, but then if I'm going to be testing the behavior of the system, I have to be testing a couple of microservices together, which testers call integration testing. So how am I going to do that? How am I going to be testing for security? How am I going to be testing for performance? It gets challenging when this is a distributed system. Latency. Obviously, in microservice architecture, the inter-process communication between each microservice and the other most probably happens over the network. So when anything happens over the network, this introduces latency. And this is a challenge. How can we guarantee that this distributed system has the least or lowest latency we can have? Last but not least, data consistency. If you're going to go for the design approach where each and every microservice is going to be having its own data store, and you're going to have transactions that are going to be carried out on a number of different microservices, how are we going to ensure that the data is consistent in each and every microservice? If we're going to be applying patterns where data must be synchronized between data stores owned by separate microservice, how are we going to handle this data consistency? So it's a challenge. It's not as easy as how we used to do it in monolithic architecture. So take care that microservice architecture, yes, it does come with a lot of benefits. It does bring you a lot of advantages, but all of this doesn't come for free. There is a cost to that. There are challenges. There is complexity, and you need to study this very well before deciding to go for such an architectural style. Microservices offer a number of design patterns, obviously to handle the different things we have just discussed right now in terms of decomposition. How are you going to be breaking your system into microservices? There are a lot of patterns for that. And today we are going to be talking about the Strangler pattern and the sidecar pattern as well. Integration patterns, there are basically a lot of those, and you will need to read about those. And you have the database patterns, observability patterns, and cross-cutting patterns. So different patterns which make microservices microservices. And you will need to use a couple of patterns with each other. Sometimes you won't be able to have patterns with other patterns. Sometimes you can have under the same category of patterns, you can use different patterns together. So what this slide is trying to tell you is that microservices offer a lot of design patterns which makes them microservices. And we are going to be using a lot of these patterns in the coming sections, the design part and in how to use Istio to migrate from monolithic architecture to microservice architecture. We're basically going to be using a lot of these patterns, and Istio actually brings you a lot of these patterns out of the box. So you don't really have to be implementing those patterns. All you have to do, or all you have to know, is that Istio gives you this pattern out of the box, and this pattern does 1, 2, 3, 4. Microservices, as we've said previously, they have a number of enabling technology. So these technologies are containers. As we've said before, containers are one of the areas in IT transformation, and an example of a containerization technology is Docker. Container orchestration, basically when you have a lot of containers that are going to run on multiple machines, and you want to make sure that you will have discoverability, you will be able to do some scheduling. If one container fails, it will be provisioned in another node, etc., etc. You need container orchestration for that, and one of the most famous technologies for doing so is Kubernetes. Service mesh, which we will talk about in the coming slide, is another architectural style or enabling technologies for microservices, and we're going to talk about that later on. Streaming is another enabling technology, especially if you're going to be applying event-driven architecture or these kinds of architectures, and you have enabling technologies for doing so, and one of the famous perhaps technologies for that is Kafka. And last but not least, public clouds. Again, we've said that cloud is one of the areas of transformation in terms of infrastructure, and one of the most famous cloud providers is AWS, Microsoft Azure, GCP by Google. So these are basically enabling technologies which will allow you to implement microservice architecture in an efficient and in a convenient way to be able to really leverage all of its benefits and advantages. And last but not least, in the theory part, okay, we're going to talk about service mesh. So if you recall a few slides back, some of the pain points which we have discussed were basically colored in blue. Developer experience, monitoring and troubleshooting, handling failures, security and testing. These are areas that could prove quite challenging in microservice architecture. So enter service mesh to try and really ease these pains and make them easier, okay, without the developer having to do a lot of effort to handle these pain points. So what is a service mesh? Service mesh is a dedicated infrastructure or communication layer for facilitating service-to-service communication between services or microservices using a proxy, which is also known as a sidecar. And if you recall from the previous slides, a sidecar was one of the patterns of microservice architecture. And that's why we've said previously that when we're going to apply one of the enabling technologies, which is service mesh, and that is Istio, Istio is going to provide us with a sidecar implementation which is going to be injected to each and every microservice in order to facilitate service-to-service communication between our microservices. So having this dedicated communication layer can provide you with a number of benefits. Some of these benefits include providing observability into the communications. So basically, what your sidecar proxy is going to do is collect information from the traffic that is going back and forth between microservices. It's going to send this information or this data to some sort of control plane, which will provide you with the observability part. And the benefit of having observability is that it can assist in the troubleshooting part in the pain points in microservices. The second benefit Service Mesh provides is that it provides secure connections. What a Service Mesh framework does is that it can offer you the capability, for example, of mutual TLS, because when you're deploying microservices, some people always imagine that these microservices are going to be located on the same server or in the same data center, when in reality it does not. When you design your application to be deployed in the cloud in microservice architecture, obviously one of the things you would want to do is to have your architecture distributed across different availability zones. Now, when we say availability zones, we mean separate data centers that are not within the same, perhaps, facility. And so when microservices are going to exchange data, obviously this is going to be going from one data center to another or from one building to another. So this has to be secure. So if you want to do that without having a service mesh framework like Istio, it's going to be a big problem because you have to manage the TLS certificates for each and every microservice independently. But when you have service mesh, the service mesh framework does all of that to you out of the box. Automatic retries and backup for failed requests. We're going to be discussing that later on, but it's one of the benefits that service mesh offers. Traffic management. Obviously, you can configure each and every microservice using its sidecar to be able to manage traffic coming in or going out of the microservice, and also handle things like canary releases, load balancing, etc. Policies, all of that. All of this is part of traffic management, and you get all of that with Service Mesh. Last but not least, when you're applying the sidecar pattern, you're separating your application's business logic from all of the previous parts we've just mentioned. So all you have to worry about when you're writing the code of your application is to just worry about the business logic, and then you leave the configuration of the observability, security, and the traffic management to the Service Mesh framework, and separate that from your business logic. So this is a big advantage. You won't have to write code to achieve such stuff, and you will have better separation of concerns and better loose coupling, basically. So to sum up, what Service Mesh offers you is the ability to connect your microservices together, secure your microservices, and monitor your microservices with a number of technologies which your Service Mesh framework is going to offer. So this covers the theoretical part about microservices and Service Mesh. We can take 2 or 3 minutes as a break, and if anybody has any question, please send it to me over the chat, and I will be answering it during the break. So waiting for your questions, and if there are no questions, we will resume in 2 or 3 minutes max. Okay, so I see there are no questions on the chat, so maybe we can move on. And of course, feel free to send me your questions at any time. Okay, so as we've said, we've covered the theoretical part. Now let's start talking about how we design for the migration of legacy monolithic applications to microservices. So you have two approaches which you can apply to migrate from monolithic architecture to microservice architecture. You've got the Big Bang approach and you've got the gradual approach. So let's start with the Big Bang approach. So in the Big Bang approach, what you basically do is that you keep your monolithic application as it is and you start rewriting it again in microservice architecture. So this of course comes with a set of problems, and this is usually not the approach that is recommended for migrating to microservices. So what are the problems with the Big Bang approach? The first problem is that most probably your monolithic application has grown so large and it has grown like that in a long period of time. So obviously you will require a similar amount of time, perhaps a little bit more, perhaps a little bit less, in order to be able to rewrite this whole monolithic application to microservice architecture. And you know, business always has demands, they have change requests, and they want that to be done very quickly. And so they can't really wait until you are done with your microservice architecture until they can start asking for more stuff in this application. So that's the first problem. And this brings us to the second problem, that it will be almost impossible to make the current monolithic application stop evolving to wait for the new microservice-based application to be ready for use. So what you will be doing is that you will be maintaining your monolithic app, you will be evolving that, and at the same time, in parallel, you will be rewriting that app again in microservice architecture. So the monolithic app is always going to be a step ahead of the microservice architecture, basically the migration that is going on in parallel to microservice architecture. Which brings us to the third problem, is that it's never going to end, and most probably at the end of your development process for the microservices, if you have not really touched the monolithic application, or the monolithic application has evolved ahead of the microservice application, the microservice application is going to be out of date. So basically, the Big Bang approach takes a lot of time because you're going to be rewriting this whole big application to microservice architecture. So it takes a lot of time, and business cannot wait until you finish. The second problem is that business is probably going to be asking for evolutions in the monolithic app. And so the monolithic app is always going to be ahead of the app that is developed in microservice architecture. And at the end of the road, you may end up with an application developed in microservice architecture that is outdated in terms of functionalities. So we recommend going for a gradual approach in order to not meet the three problems we have discussed earlier with the Big Bang approach. So what does the gradual approach say? So the gradual approach basically says that monolithic functionalities can be extracted gradually to be implemented in microservices by splitting the monolithic application into layers. Such microservices include business functionalities exposed as API calls. They can also access the monolithic database or have their own autonomous database. And we're going to be discussing all of that in our coming example. Many patterns exist for splitting monolithic applications. One of the most useful and commonly used technique is the Strangler fig application, which is a decomposition pattern which we have seen earlier in the big catalog of patterns for microservices. So what's a Strangler fig application? So a Strangler fig is basically a type of plant or tree where you have the original tree with its original branches, and a Strangler branch grows next to the original branch, and then a number of other branches start growing from that branch. So basically it becomes a strangled tree, and then the older branches die and you're left with the Strangler fig. And I think it's very clear from the graphics and the image you see in front of you. And so with the Strangler fig application, basically we are dealing with our monolithic application, and we're going to be migrating the monolithic application in the same way as a Strangler fig evolves or comes to being. So we can consider our system as the original tree, and then we're going to be splitting parts of that system into microservices, and we will keep the legacy system as it is, but we're going to configure a sort of router so that that part of the functionality that has been split as a Strangler branch would have the traffic routed to it. And we're going to be doing this splitting incrementally, so that we would be having a hybrid system similar to the strangled tree, until we have a system that is only composed of microservices, and then we can decommission the older legacy system and have our microservice architecture completely in place and running. So this is where the Strangler fig application came from. And if we're going to read the definition in the context of software, the parallel here is to have our new system initially be supported by the existing system. The idea is that the old and the new can coexist, giving the new system time to grow and potentially entirely replace the older system. So this is a much better approach than the Big Bang approach, because you will be having both systems running in parallel. Split functionality will be running in microservice architecture. Older functionality which has not yet been split will remain in the legacy system. In the transitional phase, you're going to be having a hybrid system. And then once you have split all of the functionality, all of the legacy functionality into microservices, you can basically decommission the legacy system. So of course, this happens in stages. Those are 4 stages. So the first stage is to identify parts of the legacy application that will be migrated. And one of the ways you can identify these parts is by applying domain-driven design. This can be used to identify the various bounded contexts which are going to represent microservices. The second stage is transformation. This is where you implement the identified functionality that is to be split into a new microservices. The third stage is coexistence. This is where you leave the existing module in the legacy application as it is, but you incrementally reroute calls from the monolithic application to the new microservices. So as we've said previously, you could have a router that can either route all of the traffic to that specific functionality, go to the new microservice, and route all of the other functionality to the legacy system. Or you can do a sort of a canary release where maybe 80% of the traffic will go to the older legacy module, 20% will go to the new microservice in order to be able to test it, make sure that it works fine, it meets the functional requirements and non-functional requirements, and then you can switch all of the traffic or 100% of the traffic to that new microservices. And one of the good things about applying Istio is that it can let you apply such canary releases very easily by means of a simple configuration. You will not need to write any code to achieve that. And then the final stage in the Strangler fig application pattern is to eliminate. And that's the part where I said you can have 100% of your traffic go to the new microservice, and you can eliminate the legacy module totally. You can remove its code from the legacy application and redeploy it, or simply just have it there, which is not really good practice, but you could just keep it there, but it will not be of any use. No traffic will be routed to it at all. So this basically covers the design. So when we are designing for migrating to microservice architecture, we recommend that we apply the gradual approach, where you gradually move from the legacy system to the new system that is based on microservice architecture, based on the Strangler fig application pattern, which states that you will start with the legacy system, you will identify the parts which are going to be split, you will then implement these new functionalities, both systems will coexist, and then when you're sure that your new microservice is stable, then you eliminate that older part. And when you do that in a gradual manner to each and every functionality in your legacy system, you end up with a Strangler fig application where you only have the Strangler branches and you eliminate, or the original branch dies out. Okay, so this covers the design part. So does anybody have any question before we start moving to the implementation part? Okay, it seems we don't have any questions, so we can move on. And of course, feel free to send me any questions on the chat at any time. So let's move to the implementation part. So, as the title of the session suggests, we're going to be using Istio as an enabler for migrating from a monolithic app to a microservice-based architecture. Previously, we have discussed the benefits of microservices, why we should be moving to microservices, their pains, and what service mesh brings in order to facilitate some of the pain points in microservice architecture. And we've said that one of the enabling technologies in the service mesh part is Istio. So why Istio in particular? Istio offers you everything you need from a service mesh. This includes the connect part, which we have discussed earlier. So it gives you the capability to be able to apply traffic management by various components it offers, such as virtual services, where you can basically define your weighting to the weighting of the traffic, how is it going to be distributed, etc., etc. Destination rules, which give you the capability to apply load balancing, gateways, service entries, and sidecars. It also gives you the capability to do security in terms of ICM, authentication, and authorization. And it gives you the capability to do observability by collecting metrics that would allow you to check the health of the microservice. It also collects information which allows you to do distributed tracing and the capability to acquire access logs. Istio is Kubernetes native. So basically you can extend it and you can do all the other good stuff which you can do with Kubernetes with it as well. It's based on free and open source software. So all of its components are based on FOSS. So you can always contribute to it, extend, maintain, do whatever you want, and you don't really have to be paying licenses or any stuff like that. And it relies on other FOSS. I think I said that with the third point. So Istio applies the sidecar pattern using Envoy Proxy, which is an open source project. It gives you distributed tracing using Jaeger or Zipkin, which are also open source projects. It collects health metrics and gives you the capability to monitor your microservices using Prometheus and Grafana, which are also free and open source. And it gives you this wonderful tool to see your service mesh and to be able to maintain and modify this service mesh by a wonderful GUI using a tool called Kayali, which is also free and open source. So you've got these four benefits which definitely make Istio a really good choice for applying service mesh. Now we are going to be looking at an example, a monolithic application that we are going to split using the Strangler Fig application pattern, and we are going to be using a mix of cloud, Kubernetes, and Istio to realize this migration. So before we start, we're going to be making a number of assumptions. So the first assumption is that the legacy application is a modular monolith. Okay, so you've got different types of monolithic applications, and here we're going to be assuming that this is a modular monolith. Now, in real life, you may not have a modular monolith to split, and so this is going to be much harder, and you will have to apply either decomposition by business capability or decomposition by subdomain in order to be able to identify what microservices you need to have and then split your services accordingly. We're going to be assuming that the deployment will be on a public cloud. Of course, we are not going to be making any assumption regarding what public cloud we're going to be using. Okay, it's going to be very generic. Kubernetes cluster is installed with Istio, so we're not going to be covering the part where we have to install Kubernetes on the cloud and we install Istio on top of this Kubernetes cluster. We're going to be assuming that all of this is in place by means of using that as a service from the cloud or provisioning that using infrastructure as code, or this can be done by your DevOps team or infrastructure team. We're going to be assuming that the legacy monolithic application does not run in a container, so it may be running right now on a VM or on a physical server. We're going to assume that the Strangler fig application pattern will be used for splitting the monolithic application. So no big bang approach here. We're going to be using a gradual approach. And the last assumption will be that the complete database decomposition will not be covered. So we are only going to be covering in details how we're going to be splitting the application part. Okay, the database part, we are going to be covering that, but not in much detail as the application part. So this is how our sample application will look like. As I said, it's a modular monolith. It has got 3 layers: a presentation layer, a business layer, and a persistence layer, which is the common layers you find in a monolithic backend application. The monolith basically offers 4 functions or services, okay, each identified by one of the shapes in the legend below. So our target right now is to split this monolith into 4 microservices, and we're going to be using Istio as an enabler for that. So the first step we're going to do is that we're going to be starting with our monolith, okay? And what we are going to do based on our assumption is that we will need to package that into a Docker container and deploy that into our Kubernetes cluster, which runs Istio. So in order to realize this first step, the CI pipeline of the application should be modified so as to package the monolithic application as a container image using whatever containerization technology you want, and upload it to an artifact repository or a container registry. So if you have a CI/CD pipeline, what you want to be doing is that you will want to package your monolithic application into, say, a Docker image, and upload that Docker image to some sort of artifact repository or container registry, such as JFrog Artifactory, Nexus. If you're using GitLab, you can put that in your repository on GitLab, or you can basically upload it to Docker Hub. Your CD pipeline should be configured so as to trigger the deployment of the application to Kubernetes. So once you have a Docker image in your artifact repository, you will need to configure your CD pipeline in a way that would allow you to choose that specific image and choose to deploy it to your Kubernetes cluster. You will need to configure an Istio ingress gateway, and this should be deployed and configured to your cluster in a way to route all of the traffic coming to your cluster to the monolithic application. It is very important to have an Istio ingress gateway deployed to your cluster, because we will be using that later on in order to route traffic to the newly split microservices once they're there. And last but not least, you should be configuring your DNS so that it would map your domains to the new Kubernetes cluster. So if you are on some other infrastructure and now you have your monolithic application running on Kubernetes, you will want to basically route your traffic from that older infrastructure to your new deployment, basically, or running application on the cloud on the Kubernetes cluster. So you will be having something like this, and basically the nice thing about Istio is that once it is installed in your cluster, you can configure it in a way so that every time you deploy and run a pod on your Kubernetes cluster, it will automatically inject a sidecar, and that's going to be an envoy proxy to your Kubernetes pod, so that you would get the other benefits, the virtual services, the destination rules, the security configurations, and it would be able to collect data so that you would be able to make use of observability. All of this is out of the box. You just do a very simple configuration on Kubernetes, and every time you deploy a pod to a certain namespace, Istio injects the envoy proxy into your pod, and it does the rest of the magic. Okay, step 2 will be to split service 1. So service 1 is identified by the rectangle, by the triangle sign, and we want to split its different implementations and the different layers to a separate microservice. So a development team is going to start doing that, and once this is done, you will configure your ingress gateway so that it would route traffic from legacy service 1 endpoints to the new microservice 1 endpoints. And as I've said, one of the things that Istio offers is the ability to apply canary releases, where you can have a certain percentage of your traffic going to the legacy service and others going to the new microservice. This is the coexistence stage in the Strangler Fig application. And then once you're sure everything is going well with the new microservice, you can basically eliminate or terminate the older service, and maybe you can remove all of its code from the monolithic application. So this is basically how things are going to look like on your Kubernetes cluster after you do the split. So you're going to have the new microservice coexist with the older monolithic application. In a certain stage, some of the traffic is going to be routed to the monolithic app, and other is going to be routed to the new microservice. And then once you're sure this new microservice is okay, you can stop traffic going to that specific functionality in the monolithic app and have it all go to the microservice app. And you will keep the other traffic going to other services going to the monolithic application. Now, we want to start splitting service 2, but splitting service 2 is not going to be as straightforward as splitting service 1. Why? Because service 2 business layer needs data from the business layer of service 4. Now, when this is a monolithic application, this is very simple, okay? It's a matter of just injecting the business layer off service 4 to service 2 and basically calling it within your application and getting whatever functionality or data you want. So, but in microservice architecture, as we've said, these kind of calls are going to be done over the network. So how are we going to handle that? So you're basically going to be presented with one of 4 cases, or perhaps 2 cases in combination with each other. So the first case you may be presented with is a presentation layer exposes business layer functionality as a web service. So this is where your monolithic application is designed in a way where the business functionalities are exposed by the presentation layer using web services. So this is going to make things a lot easier. In some other monolithic application, the business layer is exposed as a web service to the presentation layer. Okay, and this is also going to be good in the splitting phase. Now things can be a little bit tougher. You can have your presentation layer not expose business layer functionality as web service. Your presentation layer can basically be some sort of back end for front end. Okay, so it may not really give you the exact data or functionality you want from that specific function in the business layer. And the fourth case you may be presented with is that the business layer functionalities are not exposed as web services and are called as functions or methods. So let's see how we are going to handle that. So if you have case 1 or 2, what you will basically do is split service 2 into a separate microservice. And since the functionality in the business layer of service 4 is already exposed as a web service, you can basically configure your envoy proxy so that any call to that specific web service is going to be routed to the monolithic application so that this specific functionality is going to be called and is going to be returned back to microservice 2. So this is when you've got some sort of web service in the presentation layer or in the business layer exposing the functionality that is needed in service 4. But if you have case 3 and 4, this is where things are a little bit more difficult. But lucky for us, there is a pattern for handling that called branch by abstraction pattern. So what you will basically be, so this is where the functionality that is needed by service 2 and service 4 is obtained by means of calling a method or calling a function. So the way you're going to handle that is that first, you're not going to be making a direct call to that method in that class. You're going to be creating some sort of interface, and you're going to have 2 separate implementations for that interface. One which is going to be based on a standard classical method or function call, and another which is going to be based on a call to a microservice, which we will be using once we do the split. So this is represented basically by if you look at the box in the middle, the black box in the middle, okay? And then the second thing you're going to do is that you're going to create a web service that is going to expose the functionality of the method or the function you're calling in service 4. And you're going to consume that functionality with the web service client implementation you have done in Service 2. So basically, you're going to end up with the box on the right. So the business layer in Service 2 will no longer directly call the function or method in Service 4. It's going to be calling it by means of an interface. This interface is going to have an implementation that is based on a web service client, and that web service client is going to call the web service that exposes the functionality of Service 4. And then when you split, this is how things are going to look like. Service 2 is going to be calling the web service exposed in the Monolithic app in Service 4, and it's going to get the data it requires. So basically, we're going to end up with something like this. We're going to have our remaining microservices this way. I got a little bit confused. So this is how the microservice is going to look like after you've split microservice 2. And then when you split microservice 4, this is how everything is going to look like. So now we basically have microservice 1, which has been split easily, microservice 2, which has been split. Before splitting microservice 4, it would call the monolith in order to get some data from service 4, but then after the splitting, it's going to call microservice 4 directly, and we're going to be left with service 3 in the monolithic app. And once we split service 3 into a separate microservice, we're going to end up with this structure which you see in front of you. Does it look familiar? Yes, it's a Strangler Fig application where now basically the older monolith, yes, it does exist, but no traffic is routed to it anymore. All of the traffic is being routed to the new microservices, and once you're sure that you now have stable microservices, you can dismantle the older monolithic application and you end up with a microservice architecture. What about the database? We haven't spoken about the database. So what you can do with the database is that you can start first with a shared database. This is a pattern in microservice architecture. Some people consider it as an anti-pattern, but you can always start with a shared database that is called by your different microservices, and then you can start splitting the database in a gradual manner in the same way we did with the application part. There are many decomposition patterns for the database. There is a book I'm going to recommend to you at the end of the session, and it does explain to you how you can split the database part. And don't forget that if your database is a tier that is out of your Kubernetes cluster, you will need to manage the traffic that is going to the database and coming from the database. So you will need to consider applying an Istio egress controller that can be used to control the traffic to the database if the database is not deployed within your cluster. Perhaps you have migrated to RDS or some sort of database as a service, and it is not really part of your Kubernetes cluster. And so you will need an Istio egress controller for that. So if your Kubernetes cluster and your database are on the same VPC, virtual private cloud, and you're going to be using a shared database, this is how your cluster is going to look like. Once you do the split, this is how your cluster is going to look like. So basically each microservice is going to be having its own database or data store, and traffic going back and forth between the Kubernetes pods and the databases is all going to go through the Istio gateway. So is that it? No. Istio comes with other goodies. As I've said, one of them is Kayali, that gives you this great visualization of your cluster, and it gives you the capability to modify configurations of your cluster. We spoke earlier about destination rules, applying load balancing, applying canary releases, all of that. So you can do all of that using Kayali. But if you are applying GitOps or you're applying infrastructure as code, it is not recommended that you do your modifications to the clusters using Kayali. You can use Kayali to test some configuration, but then once you have tested this configuration, you have to do that configuration in its corresponding YAML, and then commit this YAML to source control, and then apply this new YAML to your cluster. As we've said, you can do client-side load balancing, you can do canary releases, you can do header-based routing. If this is something that is required, you can have different versions of your microservice, and you can distinguish between each version of the microservice, perhaps using a sort of a header. You can inject faults in order to see how your system is going to react towards faults. So you can do that easily with Istio in order for you to test the robustness and the fault tolerance of your cluster or your design or architecture. Istio also supports circuit breaking, so you no longer need the component like Hystrix for that. If you're using the Netflix stack, you can apply circuit breaking using simple configuration in a YAML file, and you can with many different rules that are needed for circuit breaking. Last but not least, mutual TLS. As I've said, don't rely on the fact that all of your pods will be running on the same machine. No, they may be running on different servers or even different data centers. So you need to secure the traffic that is going back and forth between your microservices. This is a mistake many people do. They say, as long as it's my VPC, as long as it's my private subnet or my basically private domain, then I don't need to secure the traffic. No, you need to secure the traffic. And the good thing about Istio is that mutual TLS is enabled by default, so you don't need to do any configuration to secure the traffic going back and forth between your microservices. This is enabled by default. So if you need to configure something, you will shut off or shut down mutual TLS and not the other way around. So this is basically it. So let's conclude what we have talked about. So migrating to microservices is a hot area in application architecture transformation. Migrating to microservices requires lots of enablers such as containerization and container orchestration on the cloud. Service mesh adds a lot of benefits to your software architecture. We've seen that when we discussed the different features of Istio, and we saw when we were migrating to microservice architecture how much the features of Istio can provide you with benefits and ease this migration. Istio is a wonderful enabler for migrating to microservices and service mesh architecture, offering the capability to implement a lot of patterns easily. So thanks a lot. Please feel free to ask me any questions after the session on one of my social media accounts. Leave me a comment on the video on YouTube. Add me on LinkedIn and send me a message, or add me on Twitter and send me a message. I used these 4 books to prepare for my presentation today, and these are recommended readings: Building Microservices, Monolith to Microservices, which discusses many different patterns in order to be able to migrate from monolithic architecture to microservice architecture. Microservice Pattern for Chris Richardson. If you access or you go to microservice.io website, this is basically the book that contains all of the different information on that website, but in much more details. Last but not least, if you want to master Istio, I recommend Istio Up and Running. It's a very good book, and it will certainly allow you to learn Istio and be able to implement it. Feel free to send me a message so that I would recommend videos and courses to you on these different topics as well. So thanks a lot. I'll wait for a couple of minutes in case you have any questions, and if I don't receive any questions in 1 or 2 minutes, I'm going to end the stream here. So we'll be glad to receive your questions if there are any. Okay, it seems there are no questions, so thank you a lot for attending, and I hope you found this session useful, and see you in coming videos and sessions.